Okay, so this is the first important rule of differentiation. Okay, which comes from the binomial rule. So I've already looked at the derivation of differentiation for x square. The others are going to follow from that logic. So, so d by dx of anything, this is going to represent differentiation of the function with respect to x. Okay, so d by dx is basically differentiation with respect to x. So if you have any function, let's say g of something k, okay, so g of some function k, then dg by dk is differentiation of g with respect to k. What does that mean? It means that uh, change in value of g of k. I'm using function g and k because f and x are too often used. So I just want to say that it's not related to x. I mean, it's about variables. Variable could be a, variable could be x. Function's name could be g, it could be f, it could be anything. So uh, the d here remains same. D is not a variable. Okay, so d remains same. What changes is the variable. What changes is the function form. So so change in value of g of k as k changes or increases by 1 unit. Okay, so you're going to change the value of k by 1 unit. How does that change the value of the function g? Okay, so let's take this example f of x equals to x squared. So at x equal, so I know that yeah, so I know that f of, okay, Kashish, you have accidentally written something. What's this? Okay, so I know that f
Added by
of,
mistake.
yeah, it happens with me as well, so it's perfectly fine. F of 2 is equals to 4. Okay, now suppose I change this value of input x to 2 plus 0.01. So what is this thing going to be? So this is going to be 2.01 whole square. So I change it by 0.01 and this thing changes by 2.01 square. So if I put a graph here, so x square graph looks like this. So this is the value at 2, it is equal to 4. And at 2.01, at 2.01, let's say here, it is 2.01 square, whatever that value is. Okay. uh, so the change in value of f, delta f, this has been 2.01 square minus 4. So this is the change in value of f as x has changed from 2 to 2.01. So this is my delta f and this is my delta x. So delta f is equals to this thing as delta x is equals to 0.1 at x equals to, at x equals to 2 is important because you're going to notice different values of change for the same delta x depending on what your starting point is. So if your starting point would have been, let's say, 1, Then for the same change in the value of x, that is at 1.01, the difference would have been different. Here the value was 1, here the value is 1.01 square. So the change here in value of f might be different in the change here. So the change is dependent on what your starting point is. Okay. So what I want to find here is, what is this change at this point exactly? So here I have found out the change for a finite delta x equals to 0.01 change in the input value, right? I want to find what is this change exactly here, exactly at that point. Okay, so right now I found the change for this interval between 2 and 2.01. I don't want to find it at an interval. I want to find it at this thing. So when I write it as delta f by delta x, which is basically 2.01 square minus 4 upon 0.01, this is the change in functional value over an interval. And when I write df by dx, whatever that value may be, I'm going to look at how to find that value. This is basically change in functional value at that point, at exactly that point. So delta f is a finite change. Delta f by delta x is a finite change. Df by dx is a infinitesimally small change. So this, as I make this delta x tending to 0, what I get is this. So limit delta x tending to 0, delta f by delta x is basically df by dx. So what's happening is that, let me draw a larger figure. So this is my graph for x square. I'm starting at point 2. Now, depending on what delta x I take, I will get different values of the slope. Suppose I take this delta f, so I get the value of slope as this much, right? But if I take this delta f, if I take this delta x, then the value of the slope is this much, which is going to be different, right? So for different values of delta x, I'm going to get different values of delta f. So delta f by delta x could be different. The slope is going to be different. As you can see from this graph, the blue slope is smaller than the green slope. It's perfectly okay. What I want to find is what happens as this blue line comes to fall on the red line. What happens to this slope? What is the limit? So that's why I say that df by dx is nothing but limit delta x tending to 0, delta f by delta x. So you write it as d by dx. So writing by d by dx of x to power n, what I'm saying is consider the function x to power n, and then tell me what is going to be its uh, its slope. D by dx is nothing but slope at that point, slope of the function at that particular point, this point. So I'm going to ask you what I'm asking is, what is the slope of this function x to power n at any point x? Okay. So if I have x to power n, the property says that d by dx of x to power n is n times x to power n minus 1. So this is the first rule that we have. Okay, now for different values of n, you can substitute this. So let's say I give you an example. Find the slope of x to power 4 at x equals to 2. So find the slope of x to power 4 at x equals to 2. So what I'm going to do is first I'm going to find the general function of slope. So d by dx of x to power 4, this is going to be by this formula 4 times x to power 4 minus 1. So that is 4 times x cubed. So this is the graph of slope of any function of this function at any point x. And then I make this substitution. So this becomes 4 times 8. So that is 30. So if you have this graph of x to power 4, okay, x to power 4 is going to look like this. Then at the point 2, the slope of this curvature is going to be 30. Okay, so the slope at point 2 is going to be 30. So let me give you an example now. Find slope of x to power 7 at x equals to 1. What is this going to be?
7x to the power 6.
And okay, so f prime is 7x to power 6. And then when you make this substitution,
7.
yeah, so that is your that is how we do it. So there are different. So sometimes they will give you the value of x to find the difference, the slope. Sometimes they won't. So as you can look in these examples, they have not asked the particular slope at any point x. Now the beauty of this formula is that this works even if this n is not is any real number. Okay, so it could be any real number, it could be any rational number basically, or irrational number also for that matter. So it works for all real numbers. So suppose you have x to power half, right? So that is root x. So root x is basically x to power half, and I want to find the differentiation for x to power half. So I can write the same rule. So differentiation d by dx of x to power half is going to be again half times x to power half minus 1. So that is half times x to power minus half. Okay, so that is going to be 1 by 2 root x, which brings me to the next example. Find d by dx of x to power 1 by 3 at x equals to 8. What's going to be this one? What's going to be the answer?
1 by 3, 8 to the power minus 2 by 3.
Just substitute. Okay, have you substituted the value of x
1
and
by
given me the
12.
answer? Okay, you're saying 1 by 12. Okay, so let me see. So this differentiation becomes 1 by 3 x to power minus 2 by 3. So that is 1 by 3 times x to power 2 by 3. So this becomes 1 by 3 times 8 to power 2 by 3. Now what is 8 to power 2 by 3? So this is 1 by 3 times 8 to power 1 by 3 whole square. All right. Now 8 to power 1 by 3 is cube root of 8. And I know that cube root of 8 is 2. So 3 into 2 square. Right. So 8 to power 1 by 3, that is 2 whole square. So that is 1. So similarly, you can look at the problems here. You can skip these things. These things are not important. Okay, so you can. Hello. Hello. Okay. Yeah. So you can skip these things and you can straight away jump to these problems. Okay. So how about you guys to do this one? Find f prime of 2.
So is it 4 pi?
Yeah. So pi r square differentiation will be, so pi remains as it is because it's a constant into 2r. So that is 4r. First, I 4 pi because you're substituting r equals to. So this is another rule of differentiation, which is basically d by dx times c of f of x is c times df by dx. Okay, so if the function is multiplied by a constant, okay, so if the function is multiplied by a constant, you can take constant out and just differentiate the function. So so I had to differentiate pi r square. Now, what is a constant? A constant is something which does not change with respect to x. Okay, so the concept of constant is something which is going to be challenging at times. Like, what do I consider as a constant? Right. So suppose the uh, okay, yeah. So suppose you have a function f of x comma y is equals to 3xy, right? So if I have to differentiate it with respect to x, suppose I write df by dx. So the biggest question always becomes is why constant with respect to x or not? All right, suppose it is not. Suppose y is actually dependent on x. Suppose y equals to x square. So first you need to substitute this y equals to x square into your uh, x, and then you need to differentiate. So a very simple example from economics is profit of a monopoly. So profit of a monopoly is price into quantity minus cost. Let's say marginal cost is fixed as C1 into quantity. Okay. So if I want to differentiate, if I want to find the quantity at which this profit function is maximized, so what I'll do is del d pi m by d. And if I just assume this to be a constant thing with respect to quantity and differentiate it, what I'll get is P minus C1 is d pi m by dq, which should be equal to 0, which implies P is equals to C1. But I know that this is not true. This is not the relationship for a monopoly. A monopolist profit maximization is marginal revenue equals to marginal cost, not profit equals to marginal cost. The reason this is happening is that I'm assuming price to be independent of Q, which is not. Price is itself a function of Q. All right. So in your journey as an economist, a lot of times you'll have to make this call when is something independent of X or Q or whatever, and when it is not. C1, if marginal cost is constant, then C1 can be assumed to be independent of quantity. But if marginal cost itself depends on quantity, then you have to basically take this as C1 of Q and then differentiate this thing as well. So it becomes more complicated when you have a functional form like this, and it will not be just P minus C1. So we'll look at how to do those things when we reach there. The idea here is, why is this pi constant? Because pi is a constant. Pi is a constant, 3.1 something. Okay, so pi is a constant irrational value. So it does not change with respect to anything. So when I am differentiating df by d of pi r square by dr, I can write this as pi times d of r square by dr. Okay. So this pi, which is multiplied with r square, gets out of the differentiation. Another important uh, relation is algebra of derivatives. Yeah. So this is the sum rule. Sum rule says that if you have a function h of x, which is basically f of x plus g of x, then this implies that derivative of h of x is equals to derivative of f plus derivative of g. Okay. So by knowing all this, if I want to find, let's say, the differentiation of this thing, what is going to be the derivative of this function? Yes, Pama, can you answer this one? What is going to be the derivative of x square plus 5x? Hello, Vama. Vama, hello. Okay, Kashish,
Yes, sir. So
what is
2x,
going to be the derivative?
so 2x plus 5.
Very good, 2x plus 5. So first I differentiate. So whenever this is like a plus thing, I can separate it out and it's differentiated individually. So this differentiation is 2x and this differentiation is 5. So 2x plus 5. So now you can basically do these remaining problems. So that's going to be the problems that you have to do. So that's your sum rule. Sum rule also works for differentiation. If the function is f minus g, you can write it as plus of minus g. So if h is f minus g, h prime becomes f prime minus g prime. So that's difference rule, which is nothing but just summation rule. Okay. We have a bunch of numbers. Uh, is this a typo here? Okay, minus sign should have been given on the third one. So problem is x cubed 1 by x squared minus 1 by x. So why don't you guys tell me the differentiation of this function? Can you guys hear and see clearly?
No, so your screen is not visible.
Not visible?
No, sir.
Right. To change my okay, is it visible now?
Yes,
Yes,
sir.
sir.
So yeah, so I want you to differentiate this function. Y equals to x cube plus 1 by x square minus 1 by x. Please differentiate this function.
So is it 3x square minus 2 upon x cube plus 1 by x square?
2x upon, sorry,
3x square minus 2 upon x cube plus 1 upon x square.
okay, so that is Kanishka's answer. We'll wait for Kashish and Vama if she's with us.
So minus 2 upon x cube.
X cube.
Yes, sir.
Kashish, what are you getting?
It's the same answer.
And Vama, are you with us? Are you not with us? Anyway, so yeah, this is correct. So x cube differentiation very easy, 3x square. 1 by x square can be written as x to power minus 2. So its differentiation becomes minus 2 times x to power minus 2 minus 1. So that is minus 2 times x to power minus 3. So that is minus 2 by x cube. So this is minus 2 by x cube. And finally, 1 by x. So if I focus on just 1 by x, this is x to power minus 1. So its differentiation becomes minus 1 times x to power minus 1 minus 1. So that is minus 2. So this is minus 1 by x square. Now this minus and this minus together add up to give this plus. So plus 1 times 1 by x square. Okay, so this is correct. Okay, so you can do these problems if you want. Yeah. So these are a bunch of other problems that you should be able to handle. So do these problems as well. Yeah, do all of them. So the idea is, till when should you do it? Till the point that you can look at a problem and do it. That's the idea. Okay, so differentiation you'll be doing for at least 5 to 10 questions would involve differentiation in your exam. So if you're fast with it, you can save time in every question that you're doing. So that's why I'll recommend you to keep doing problems till you can just solve them by looking at it. So that would be better. Also, the more you practice, that reduces the probability of committing a mistake in an exam. Now, next is derivative of product of two functions. Okay, so if I want to, let's say, look at a function that is a product of two functions, so I can straight away go to this product rule. So product rule says that d by dx of fx into gx is, you keep this thing as constant, differentiate with respect to this second function, and then you keep the second function constant and differentiate with respect to first function. So this is your product rule, a very important uh, formula. So let us look at some applications. So suppose I want to differentiate this function 5x to power 6 and something. So first I'll focus on this part. So you can start with any of them. Okay, it's not like you have to start with the left one first. You can start with the right one also. The ordering does not matter, because multiplication is not ordered, right? A into B is same as B into A. So ordering does not matter in multiplication. So you can choose any of them. So differentiation of this thing is going to be 5 times 6 times 5 times differentiation of x to power 6. So that is going to be 6x to power 5 into 7x square plus 4x. Then plus, keep this thing as it is and differentiate the thing inside. So 5x to power 6 into the differentiation of this thing would be 14 times x plus this would be just 4. Okay, so that is your complete differentiation. Then you can choose to open the bracket or leave it as it is, doesn't matter. So they have done it in two ways. What are the two ways? Yeah, keep this thing constant, differentiate this, and this thing constant, differentiate this. Another way to do it is you multiply first and then differentiate. Okay. So here what they've done is they have applied product rule. They found the differentiation and then they solved it. Here what they do is they multiply first and then they differentiate. So you can choose either way, choose to go either way. The answer remains the same. Okay, so you can either multiply first and then you can differentiate, or you can apply product rule, differentiate everything, and then whatever you get, you can resolve, solve it. Okay, so dy by dx. Okay, so find the derivative. So let's do this problem. So he's given you f of x, g of x, and h of x. He's asked you to find this differentiation. So you can take a minute to do this. So let me say that I call this entire function as z of x. So I know that z is f into g into h. Okay. So z prime. So first I just club f and g. So it's going to be f into g prime into h plus f into g times h prime. Okay. Now this part is easy to evaluate. This part is something which will have again a bifurcation. So fg prime is f prime g plus g prime f times h plus f into g into h prime. So when I open up this bracket, I get f prime times g into h plus g prime times f g prime times f into h plus h prime times f into g. So you see, one by one, what I'm doing is first differentiate these, keep these two as constant, then differentiate this, keep these two as constant, and finally differentiate this, keep these two as constant, and add all of them up. So add all these individual parts. So that's going to be very helpful. Uh, so first I'm going to differentiate this. So the differentiation of this is 1, differentiation of this is also 1, and differentiation of this thing is 2x plus 1. So my final answer is going to be 1 times x minus 3 into 2x plus 1. Okay, so I kept this thing, this thing, this thing. Now I am going to keep the differentiation of this and these two as intact, plus 1 times x into 2x plus 1. Plus finally I'm going to use this differentiation. Oh no, sorry, not 2x plus 1. I should be using x square plus x. And finally, I'm going to use this guy's differentiation and keep these two as it is. So it's going to be x into x minus 3 into 2x plus 1. Right. And then you can open up the bracket and see where it takes you. So yeah. So that's how you can do this this particular exercise. So do this entire section as well. This is completely doable. Now the next part is quotient rule. The quotient rule, as the name suggests, is when you have a ratio of two functions. Okay, so this is a quotient rule. Forget the, this is all the proof. Okay, this is basically the proof for quotient rule. Nobody is going to ask you the proof for quotient rule. So I'm not interested in you doing the proofs. If you want, I've given it to you. You can go over them if you are interested. Uh, but the idea is the application is important. So I'm going to look at the quotient rule. So you can derive quotient rule from product rule itself, by the way. You can write this f by g as f times g to power minus 1. Okay, and then you can basically derive it from here. But I'm not interested in that. Just remember the formula. If you have f by g, first you differentiate the numerator, keep denominator constant. Then there's a minus sign here. Then you differentiate the denominator, keep numerator constant as it is. Okay, so f prime g minus f g prime, and denominator becomes square of itself. So the denominator just becomes the square of whatever it is. So this is your quotient rule. So let's start with a simple thing, 4x plus 3 upon 2x minus 1. But if 4x plus 3 upon 2x minus 1. Upon 2x minus 1. So remember, the quotient rule is d by dx of f by g is equals to f prime g plus g prime f upon g square. Okay, this is not power 1, this is prime differentiation. So yeah, so with that in mind, what is going to be the derivative of f?
So minus 10 upon 2x minus 1 whole square.
Can you repeat it? Minus 10 upon,
2x minus 1 whole square.
okay. This is Kanishka's answer. You can put Ashish.
So I also got the same answer.
All right, cool. So I'll not solve it further, but the idea is, okay, so differentiate this, that. So once you know these rules and differentiation of individual functions, you can basically differentiate any huge, ugly looking function that there could be. For example, something like this. Okay, so the aim is not to be able to do it. The aim is to be able to do it fast. Okay, speed is going to be, and that's why I'm giving you so many problems, because if you do more problems, you are going to gain speed, which is going to save you time in the exam. So do all of these problems that there are, and the ones that you make a mistake in, just note them down. I think they have given the answers in the end. Have they? Yeah, so the answers are all here. So you can check your progress and just mark down the questions that you made a mistake in, and make sure that you come back and do them again. Okay, so don't. So that would be a good way to do it. Okay, so do them and check yourself which ones you made a mistake in, mark them and do them again. Maybe not right away, maybe a week later, so that you have forgotten what mistake you did. And then the aim is uh, to not remember what mistake we did. Okay, so that's not the idea. If you see that you made this mistake and solve it right away, you will consciously not make that mistake. The idea is that you should not be making any mistake even subconsciously. So for that, the idea generally that works for students is that you attempt it, mark down the questions that you made a mistake in, come back to the problem 1 week or 2 weeks later and do it again. Okay, next we are going to look at chain rule. So how does chain rule work? So suppose I am given a function, like I told you, suppose I have a function of sine square x, 3 times sine square x plus 4 times sine x plus 7. Okay, and I want to differentiate this with respect to x. So notice that this is a function in sine x. Suppose I make a substitution sine x equals to t, then this function basically becomes 3 times t square plus 4t plus 7. This is a function, let's say g of t. What I have is dg by dt. What I want is dg by dx. So what chain rule says is that dg by dx is going to be equal to dg by dt into dt by dx. Okay, it's not like multiplication that you can cancel this thing out, and it's not working like that. Okay, you you can use this idea in your head to maybe remember it like that, but this is basically chain rule. We looked at chain rule in our class on Saturday. We looked at what it is, and this is basically your chain rule. So I don't care if you remember it like this. Okay, but the idea is that this works on even multiple levels. Okay, so this is just a two-tier thing. I just made one substitution. Suppose you have some function g of h of f of x of t, right? 1 2 3 4. Okay, yeah. So if I want to find dg by dt, so that would be equal to dg by dh into dh by df into df by dt dx into dx by dt. You see, things cancel out, although that is not how you should think that it works. It's not how it works, but you can remember it easily like that. You can verify if you're doing it correctly. So let's come back to this question and see what happens if I do it like this. So dg by dt, what is going to be dg by dt? So this is my g of t. If I differentiate it with respect to t, I'm going to get 6 times t plus uh, 4 times plus 4, 6 times t plus 4. Okay. And then I make the substitution that t is equals to sine x. So this is basically 6 times sine x plus 4, right? So that is going to be my first thing, dg by dt. Ultimately, I have to report it in terms of x. I cannot leave it as t. Okay, I cannot leave it as t. I have to report everything in terms of x. So I make this substitution that t is equals to sine x. Next, dt by dx. So remember that t is equals to sine x. So dt by dx is d of sine x by x. So that is just cos x. So this thing is just cos x. And this thing was 6 sine x plus 4. So 6 sine x plus 4 into cos x. So that is going to be the differentiation of this complicated being. So that's your chain rule. Comes in handy a lot of times. So yeah. So you have been given this function here, and you've been asked to find dy by dx. Now, obviously, it's a complicated looking function. What you can do is you can call this entire thing as t. Okay. So y becomes just equal to under root of t, where t is equals to x to power 4 plus 8 times x square plus 1. Now, what I'm interested in is dy by dx, which will basically be equal to dy by dt into dt by dx, right? So you can write this thing dy by dt. Dy by dt is 1 by 2 root t into dt by dx. So dt by dx is going to be 4x cube plus 16x. And finally, this root t can be written as under root of x to power 4 plus 8x square plus 1. So it makes our job easier in certain situations, and that's why it's a very handy rule, chain rule. So look at these examples. Obviously, you have to look at the examples first, make sure that you understand what's happening, you're getting to the right results, and then you solve them. Try to use in these problems specifically, try to use some substitution and do it. Because if you do it without substitution, you're not learning this thing. Maybe you can do it in both the ways. Okay, you can do it in both the ways. Ideally, if you use substitution and do it better. Okay, the idea is right now I'm writing the function t and everything. By the point that you reach this function, you should not be using substitutions. If you can do it without substitution just by looking at it. Okay, like if I look at it, I know how it works. Differentiation of this guy is 1. Differentiation of this guy is going to be 1 by 2 under root x square plus 8. Okay, when I take x square plus 8 as a constant, it becomes this. And then differentiation of x square plus 8 is 2x. So by looking at it, I can do it. So you should also try to reach that level. Now, double derivatives of functions. So double derivative is d by dx times dy by dx. So that is also written as d2y by dx square. Okay, so this is written as d2y by dx square. Okay, so d2y by dx square. You don't call it d square y by dx square. Okay, so that can create confusion. So dy square by dx square is something else. Okay, this is dy square by dx square is basically differentiation of y square with respect to x square. So to avoid that, we say it as d2y by dx square. And we also don't, we write it like this. So second order derivatives, very easy. You differentiate once and then you differentiate again. Okay, so let me give you this one, x plus 1 upon x minus 1. Give me double differentiation of this. Okay, so suppose this is f, so find f double prime of x. So first you have to differentiate it once, get the function, and then again differentiate it. So that then you'll get your f double prime. Yeah, so first I am going to find f prime. So f prime is going to be differentiation of this thing. So that is 1 times x minus 1 minus x plus 1 times differentiation of denominator. So differentiation of denominator is 1 whole divided by x minus 1 whole square. So this becomes x minus 1 minus x minus 1 upon x minus 1 whole square. So that becomes minus 2 upon x minus 1 whole square. Right. So this is your f prime. Correct. And f double prime, you can just differentiate this thing. So you can use the chain rule here. So using chain rule, you can write this thing as minus 2 times x minus 1 to power minus 2. So f double prime becomes minus 4 times x minus 1 to power minus 3 into not minus 2 into minus 2 becomes plus 4 into differentiation of x minus 1. So that is going to be equal to 1. So that is 4 by x minus 1 whole cube. Okay, so yeah, that is the answer. 4 by x minus 1 cube. So then you can look at these different examples which I have not done in class. these three examples you can look at. You can look at this final progress level, and then you are basically ready. Okay, you're basically ready with dealing with any type of issues. So the thing is here, everything is basically polynomial functions. That is mostly the most common type of function that we deal with, but that is not necessarily the only type of functions that you are going to have to handle. But in these notes, there's these rules of differentiation for different functions. Where are they? Yeah, so these rules. So these rules combined by whatever we have learned will basically help you to solve any type of problem that we can encounter. Baki, it's all practice. Okay, so these are rules. The more we practice, the better we get at it. So we'll be doing a lot of problems which will help you gain speed and accuracy over differentiation. Okay, so I'll leave you with these problems. I'll upload the lecture for Saturday
Excuse me,
and
sir.
today's lecture today. Yeah.
Sir, while I was trying this worksheet in Check Your Progress 21.2, there's a question C part of question 3. I tried it using the delta method and wasn't able to solve it. Do we have to try delta method
No, you don't.
for ISI subjective papers?
No, in my experience, you don't need it. They've never asked it.
Okay, sir.
So you can you can ignore the delta method. But if you want, which question are you talking about?
So root x plus 1 upon root x. C
Can
part
you
of question 3.
3c root x plus
Yes.
1 by root x for x not equals to 0? Okay. What was first principles? So you're saying you are solving this using limits, right?
Yes, sir.
Okay, so root x plus 1 by root x. Uh, f of x equals to root x plus 1 by root x. Okay, so f of x plus h will be equal to under root of x plus h plus 1 by under root x plus h. Right, so I am interested in limit h tending to 0. Root x plus 1 by root x, root x plus h plus 1 by under root x plus h minus root x plus under 1 by root x whole divided by h. So I can take under root x plus h common here. So 1 by under root x plus h times x plus h right, x plus h plus 1 minus 1 by root x times x plus 1 whole divided by h. Okay. Hmm. No, I don't think it will work like this. I think this works through Taylor series. I think it would work. I mean, you can use L'Hopital definitely, but I don't want to use L'Hopital when I'm doing learning differentiation. So obviously that would defeat the purpose. I think this works with the expansion of a plus b to the power half. The expansion, say it would happen. Apart from that, okay, root x plus h can be assumed to be equal to root x, right? Root x plus h, because h is tending to 0, so these two things can be assumed to be 0 equals 1 by root x times x plus h plus 1 minus x plus 1 whole divided by h. Limit h tending to 0. So because x is non-zero, okay, x has to be non-zero. Because x is non-zero, x plus h and x are same, so I can take that as common. So this becomes now 1 by root x times h upon h. No, no, it would work through expansion. Definitely made some mistake somewhere. What is the true derivative of this thing? It's going to be a 1 by 2 root x minus 1 by 2x to power 3 by 2. So that is 1 by 2 root x into 1 minus 1 by x. So this should be it. Okay, so it works through the expansion that even I don't remember, frankly. We did it back in our engineering days, but you don't need it. Okay, so we won't need it. So it's sufficient to be able to do it using our techniques. You don't need to use delta method and aggregation method. So forget these methods. Don't do it using these methods.
Okay, sir.